So welcome to you that are joining in. I'm here with Anna Liljedahl. We're just going to give a few minutes for attendees to join the room. It looks like we're already over 20. I think we had 50 plus registered for today, so we'll wait a minute or two for at least most of those to join in, and then I've got a brief introduction from PGC, and then after that we'll turn it over to Anna for her talk, which you're all here for. So I believe as participants, you're not able to speak, but Anna, can you see the slide on my screen share?
I sure can. Thank you.
Fantastic. I'm just going to take a look at the number of people that are on, and then if we're up to a good count, I'll go ahead and get started. It looks like we're at roughly 26 participants right now, so I do expect a number will join in once we get started. But I'm going to offer a few brief introduction words on behalf of PGC, maybe 5 minutes give or take, and then we're going to turn it over to Anna, and hopefully at that point more people have been able to join in. During the talk at any time, if people have questions, there should be a place just to ask questions. Anna and I will both be able to see those, and so I think her talk, she's planning on talking about a half an hour or so. Is that correct, Anna? And then we'll open up to questions after that. So we hope to have a number of people on from PGC as well that can help answer questions. But why don't we go ahead and get started here? So first of all, a very warm welcome to everyone, and thank you for joining us today. We're really excited to be able to continue our PGC Users webinar series, the Science Speakers Edition. And today we're thrilled and honored to have our Science Operations Committee member and super user and friend, Anna Liljedahl, with us. My name is Jonathan Punsack. I'm not sure who's all on at the moment. I'll check the names later, but I hope that I've had a chance to meet many of you. If not, looking forward to having you on the call and hopefully some questions later. I serve as the Managing Director at the Polar Geospatial Center. I'm filling in today for Kathleen Torres-Parisian, who provides geospatial support and also leads our PGC educational and outreach efforts such as this. She was unable to be here today, so I'm happy to be filling in for her, and I know she's sorry that she wasn't able to join. Before we get started with you, so again, I just wanted to offer some of the details about viewing the webinar in Zoom. All the participants are muted upon entry and then throughout the webinar, and we'll have time at the end of Anna's presentation for question and answers. So throughout her presentation, please feel free to submit questions openly or anonymously in the Q&A tab, and we'll do our best afterwards to get to hopefully any and all the questions that you may have. So we look forward to hearing those questions. For those of you that are not familiar with the PGC, just a brief overview of who we are and what we do. We're a polar science and logistics center organization at the University of Minnesota. Our core funding comes from the National Science Foundation, Office of Polar Programs, and we do receive some additional funding from other agencies, including NASA's Cryosphere program. Our overall mission is to provide domain and institutional knowledge to solve a broad range of polar geospatial problems, to provide access to sub-meter commercial imagery over the poles, and the expertise to task, manage, and process imagery and other high-level value-added products. And lastly, we provide educational courses and online materials to transfer our knowledge and experience to the community, including many of you that are on the call today. Our core products and services. Our main products and services enable our mission to come to light and are best described and fall into these 4 categories. So satellite imagery, terrain models, digital maps, and geospatial support. We have a vast imagery archive and a lot of high resolution sub-meter commercial satellite imagery from Digital Globe or Maxar technologies. We have enough to cover over 95 Arctics and about 90 Antarcticas. So almost 6 times the surface of the Earth. So a vast archive and steadily growing. Many of you may be familiar with elevation products we provide. So another main product and service PGC provides are terrain models. Elevation data is central to many science and logistics projects, and we've partnered with other public and private institutions to automatically produce freely available, high resolution, high quality digital surface models using abundant digital globe or Maxar imagery. And please be sure to check out the Arctic DEM site or the reference elevation model of Antarctica, also known as REMA, on our website. Looking at our data repository, PGC stores and distributes polar geospatial data developed in-house and from external sources. At PGC, we know that maps are important tools, not just pretty wall hangings. We have hundreds of contemporary and historical polar maps searchable online in our map catalog, among other online geospatial databases. We definitely encourage you to take a look at our website. It's a fantastic resource, so pgc.umn.edu. So if you're curious to learn more, our website provides exhaustive information about the Polar Geospatial Center and what we do. So please check that link sometime after the talk if you've not been there before. The role that we provide to scientists, we have a breadth of users from the general public to Antarctic pilots, to ornithologists, to cooperative agencies. For users like Anna, our role to scientists is essentially all geared to providing geospatial expertise to enable scientific objectives and hopefully to help users reach them more effectively and efficiently. We spend our time processing and manipulating data so researchers can spend their time on their cool science. So a little bit about our webinar series. Anna's the second in the series. Dr. Mark Salvatore gave a fantastic talk a couple weeks ago. We're really excited about these. I don't need to say this, but clearly we're in unprecedented times right now. Many of us are working from home. Much of the Arctic and Antarctic field seasons have been canceled or significantly altered in some way. And so we're all trying to find ways to adapt to that. We thought that this would be a great opportunity to showcase and connect our users through their research. So our users are leaders in innovative thinking and use remote sensing techniques to reach the far corners of the world and the Arctic and beyond to discover more. We want their findings to inspire or supplement others' projects due to these exceptional changes. We are thrilled to have Anna participating in our science speakers webinar series and look forward to our upcoming guest speakers, including Dr. Andrew Fleming, Dr. Chinli Dai, and Dr. Ellen Enderlin. Stay up to date on our website or social media about registration openings and abstracts. So without further ado, I'm excited today to welcome our science guest speaker, Dr. Anna Liljedahl. She's an associate scientist at the Woodwell Climate Research Center, formerly known as the Woods Hole Research Center. She's also an affiliate professor at the University of Alaska Fairbanks. She's become a PGC super user and friend of the PGC team. Anna's research investigates how climate change is altering the movement and storage of water in Arctic ecosystems. She has innovatively utilized the monstrosity of satellite imagery available at PGC and elsewhere to help build the Permafrost Discovery Gateway and expand access to data and knowledge. Anna, thank you very much for being here and sharing your work with us and our users in public, and I'll let you take it from here.
Thank you so very much, Jonathan. I will steal the screen from you.
Please do.
Yeah. See. It says that the host has disabled screen sharing, so maybe there's a. You might need to make me co-host. Oh, there it goes. Good. All good. And I'm going to do like this. There we go. Awesome. Thank you, everyone, for joining in here today. I'm honored to be part of this series, and I think it's really being in US and here being a US researcher. There's such a tremendous resource that we have in the Polar Geospatial Center and access to this very high resolution optical imagery across the whole Arctic. It's really a treat, and I think it's setting us up well to do neat science. And today I'll be telling you about the Permafrost Discovery Gateway, which is a new project funded by the Navigating New Arctic at NSF. And we started in late last fall, and it's a 4-year project where we will enable discovery and knowledge generation from big imagery permafrost products. And we have a web page here on the Arctic Data Center website. And the team is large. We have, I think, 8 different organizations. And one of the leaders are Kenton McHenry at the University of Illinois. And with him, we have Luigi Marini, Ayman Soliman, and Todd Nicholson. And they are providing support through Clouder, so data management, and also enabling computational resources to apply the codes across the Alpine Arctic. And then the Arctic Data Center with Matt Jones and Amber Budden in the lead are the home of the Permafrost Discovery Gateway. And they're also supported by Lauren Workel and Chris Jones. And then we have Jason Cervenek, the PI from Ohio State University. And he has led the development of the Fluid Earth Viewer, which is a visualization tool mainly aimed for the public. And Vidya Yadav and Michael Gravina are on his team as well. And Shandi Vitharana is the PI from University of Connecticut, and he has a postdoc and PhD student joining us as well. And he is leading deep learning, CNN mapping using the optical imagery from PGC. And Geir Grosse and Ingmar Nitze over in Potsdam and Alfred Wegener Institute, they joined us as well. And Ingmar is taking the code that he's already published on mapping thermokarst and applying it to the Arctic. And at University of Alaska Fairbanks, we've got Ben Jones and Jennifer Moss. And then we have Alaska Pacific University and also Alaska Native Tribal Health Consortium is Michael Brubaker, and Galina Vind at NASA as well. So I'll jump over to the next slide here. So the Arctic is changing rapidly due to the permafrost thaw. That is no news. And I think here it's changing so rapidly that we barely can keep up. And that's where I think we have tremendous opportunity to use imagery, satellite imagery, high resolution imagery, to try to keep up with the rapidly changing Arctic environments. We see eroding coastlines, both in lakes and the ocean, and we have tundra fires, as well as these thaw slumps appearing in the landscape, both in the continuous and discontinuous permafrost zone. So the continuous permafrost zone, we have at least 90% permafrost cover across the area, and then discontinuous is 50% or more. And people are truly living this change, and people are experiencing the thawing of permafrost and the impact of it. Here is that the LEO network, Local Environmental Observer Network, that Michael Brubaker is leading, is a great resource to really learn what it is to live in this rapidly changing environment. And I think a great resource to get ideas for science project as well. So it's everything from river erosion to burial sites that are being exposed and so on. And they keep updating it every week. It's not just Alaska, but also Pan-Arctic. So this is important stuff. And at the same time, Arctic is changing, the data universe is expanding too. We keep creating more data, and this is happening exponentially here. This is annual size of the global data sphere, all the data, not just imagery, and it's going up. So in order to keep up with this, we really need machines, we need computers to keep up with this, and especially the rapidly changing Arctic. So that's where part of the motivation of coming up with this Permafrost Discovery Gateway project. And so here, where we can both discover and experience the Arctic from afar, or believe in the Arctic, and keep track on the changes that are happening. So Permafrost Discovery is making big permafrost imagery products discoverable for knowledge generation. So we have this satellite imagery and combine it with big computers, and then you can access it from your local web browser and explore this data using different visualization tools here. Because a lot of this data is so big that we cannot fit it on our own computers. And I I felt also I had a need to, I wanted to work with this big data. So I do not write code myself. And I wanted to work and apply this data in my hydrology research. And that's where I decided to bring these people together so we could create this visualization tool and enable people like others as well that want to work with the data, but do not necessarily have either the skills or the resources to do it. Enable science, enable discovery. So the mission is really to make permafrost big imagery products discoverable for the scientists primarily, and also to the public, but we have that as sort of a secondary audience. And the objectives is first to support the development of Pan-Arctic big imagery products. So we have Shandi, who's developed code to map ice-rich polygons. We have Ingmar, who developed code to map thermokarst and lakes. And then also Soraya Kaiser, she's at Avi, she developed code to map surface water and lake area change from the world view imagery as well. So that code is being put into the Clouder network or Clouder data management and enabled Pan-Arctic application. And the second thing is to enable exploration and discovery by the researchers and the public. So through visualization tools, so interactive maps and also graphing tools, and also geospatial statistical tools to some extent. So the overall goal is here to empower diverse people, different backgrounds, different skills, to generate new knowledge and ideas from these big imagery products. And here's the basic framework overview of the Permafrost Discovery Gateway. So we have the imagery that we're linking into wherever they're sitting, if it's PGC or Planet or Landsat. And then there's pre-processing, some which is happening at PGC. And the computing resources we've been using so far is Exceed, and also Longhorn at TTAC, and CSA at University of Illinois have a new resource, new project called Radiant as well, it's enable cloud computing. And then combine that with this automated classification and optimized workflow to really let the code loose on the across the Arctic. And then to preserve these products, then the maps that have been created, we have it at Arctic Data Center, who have extensive experience in detailed product data preservation. And so we want to make sure we know exactly what code has been used and how the product was generated. So there's a trail of information there, the history of how the data was generated. And then the discovery part is then through the visualization tools, which are building up on existing codes such as FluidAR Viewer, as you will see. And also there's tools in Google Earth Engine and other sources out there. So why is the Permafrost Discovery Gateway needed? Well, one thing I feel is really important is to try to shorten this pipeline from information to knowledge to action. So we as scientists know that we get an idea, we try to get the proposal funded, and then we do the work, and then it takes another couple of years to analyze and submit a paper and get it published. It could take 10 years, from the idea until it's actually is published, and maybe some journalists write about it in the end, and it becomes accessible to the public. So and then the public in turn can inform decisions, and stakeholders can make more informed decisions based on the new knowledge. So there's at least a 10-year time frame, and a lot happens in the Arctic in 10 years. So our Permafrost Discovery Gateway can make, still have that long scientific process in the background, but also there's a secondary option and for users to go and explore the data themselves directly. And another part is to monitor change at the spatial resolution and coverage that's relevant to people. Because the Pan-Arctic products we have so far, except for the Arctic Dam, which is 2-meter resolution and half-meter coming, is that most of those products are so coarse that it doesn't really make sense. You can't really relate to it as someone living in a community. So here we have these sub-meter resolution products being created at the Panarctic scale. And that will also, number 3, bridge the spatial gap between this field-based and Panarctic modeling studies. So finally, we're coming up with these products that are fine enough resolution that you can compare to field studies, same time they have the coverage of this Panarctic modeling studies. And so, and number 4, said before, to make these products accessible, and also number 5, to scale remote sensing applications. So we have codes that are operating at the local scales, and they need some optimization to be applied to the bigger domains. So in the end, to enable science and to enable informed decisions, that's the purpose of the Permafrost Discovery Gateway. So big imagery here, we have the resources at PGC from Digital Globe, 0.3 to 0.5 meter resolution, and its data set starts in 2007. And as Jonathan showed, is 4 petabytes of imagery now, and much more than 1 million images, much more than 1 million square kilometers of imagery. And if you're US funded, NSF funded, US based NSF funded research, this is accessible to you. And for now, the Arctic Dam is the only really accessible existing derived Panarctic product that I know of, at least, but there's more coming in the pipeline. And one example here of products in the work is Shandi Vitharana and Ezambijan and also Rahida, their work at University of Connecticut mapping ice wedge polygons. So we have, if you look in the center here, you see Prudhoe Bay and an ice wedge polygon. So these wet areas here is where we have ice wedges underneath. So these wedges of ice can be 5-8 meter deep and almost as wide as the top, and they form of thousands of years of freezing and cracking of the soil, and then meltwater infiltrating in the springtime, and they just keep growing. It's like a book. You get these layers growing outwards. And when they're happy and healthy, these what you see as a ponded area here actually is the opposite. It's a ridge. It's a ridge. It's because the wedges of ice pushes the soils upward. When you have an unusually warm summer, which has shown a couple of studies across the Arctic, this top of these ice wedges can then rapidly degrade, and you get ground subsidence and you form these pits of water. So that's what happened here in Prudhoe. And so Shandi and his team, they have manually mapped over 20,000 of these polygons, mainly in Alaska, but also using sites in Russia and Canada. And then trained a deep learning convolutional neural network model to map these features. And so you can see here mapping results from North Slope of Alaska, which is, they have more done by now too. This green is all these ice wedge polygons, and the insert in the top right, you can see more in a zoomed in area how much ice wedge polygons we have. So ice wedge polygons, mapping them tells you where you have ice-rich permafrost in the Arctic. Like you can have 70% ice content here where you have this ice wedge polygon. So imagine if you thought that permafrost, it just becomes a soup pretty much of water. And either the water stays around like in this photo, or it drains away depending on the gradients of the landscape. And another product that is being developed Panarctic is here, continuation on Ingmar's work, where he's mapping thaw slumps and also lake area change and fire scars as well. And he's using Landsat, and he's also dug into sentinel imagery, so 10 meter resolution. So this is also becoming part of the Permafrost Discovery Gateway. And here we can look more at changes in the landscape, because Landsat has a bigger, longer time series and more data than the optical imagery can offer, but of course not the same resolution. So he's using machine learning and has mainly worked on Google Earth Engine to develop this, but he'll also going through Cloudera and using some of our other resources for computing. And oh yeah, I should mention too, so in addition to Ingmar and Shandi, I mentioned Soraya Kaiser at AVI. So she is using PGC imagery, mapping surface water lake change. So I'm really excited. It looks like we're gonna be able to have a Pan-Arctic product of surface water at the sub-meter resolution. And I'm so excited, curious to see how big portion of the surface water in the Arctic that are represented by these tiny, we go back to Shandi's, these tiny water bodies that you see here that are only a meter or 3 across. And they can change rapidly too with changes in the seasonality and also the degradation of permafrost as well. So those 3 are Pan-Arctic products that are definitely in the works. And the visualization tools, this is just a draft, an idea. So this is something, it's important for the project to hear from the community what the users would like to see and how they want to interact with the data. So I welcome you to shoot me an email if you want to be part of our beta testers and provide some early feedback. We plan to have our first official version of the Permafrost Discovery Gateway released this for AGU. So not all 3 tools, but one of the tools. And so I wanted to, the main tool in the background is from Fluid Earth Viewer. So I'll show a little bit more about another side. And that's already exists, Fluid Earth Viewer. We will just add permafrost products to it. And then up on the top left here is the imagery viewer. So imagine Google Earth or estuary imagery in the background, and then you overlay your mapped permafrost feature, such as ice wedge polygon as is shown here from Shandi's work. You can zoom in and out just like you do in Google Earth. And then also on the lower left is a graphing tool. So it will be informed by this big imagery and data. And as an example here, you can plot cumulative summer warmth on the x-axis. So you add up all the degree days over the summers. And on the y-axis here is area affected by ice wedge degradation. It's a %. So each area, then each dot is representing here, in this case, a watershed. So the Lena River, Mackenzie River, Yukon, and so on. And then the size of the dot can represent the total amount of ice wedge degradation that happened. So Shandi's mapping 2 kinds of ice wedge polygons. Low center polygons, which are happy, healthy ice wedges, and high center polygons landscape that are formed after ice wedge degradation. So we can also then look at ice wedge degradation across the landscape. And you can then make little movies as well out of this graph. So the Fluid Earth Viewer is primarily climate atmospheric data and a 15-kilometer resolution and down to 3 hours. And here they're including 30-year averages and annual and seasonal, as well as anomalies, which I think will be really interesting to combine with the permafrost changes, such as thermokarst lakes or lake area change. And the tool is primarily built for K-12 and high school students and the public. So this will be our main tool where you can explore permafrost products that are more welcoming to the public user community. And the permafrost products here, we won't be able to show the sort of the original permafrost products because the 15-kilometer resolution, we will, well, that's the resolution of Fluid Earth Viewer, 15-kilometer, while the permafrost products are down to meter resolution or so, and 30 meter in the Landsat. So we will come up with a sort of a second level product from the permafrost data to show here. So I'm envisioning, you think about how people have displayed the coronavirus, the cases around the world, that you have a circle. The bigger the circle, the more cases. So here we could have the bigger the circle, the more thermokarst have appeared in a certain time period, for example. So I would be really curious to hear any ideas you might have here of how to display changes in thermokarst, changes in lake area, amount of surface water, or ice-rich polygon, like how you would like to interact with those permafrost products on top of this atmospheric visualization tool. So also what to serve on our Permafrost Discovery Gateway smorgasbord, because we have this permafrost product being developed, but we want to also back it up with existing geospatial data. And one here is the permafrost map, for example, that is from Jerry Brown and others. So we can differentiate between continuous, discontinuous permafrost. We have a newer one from folks in Europe that developed, and Arctic Dam, of course, because you can look at slope and elevation and combine your permafrost products, separate them out that way. And we also have the vegetation map, secret polar Arctic vegetation map, so you can divide up and look at how thermokarst is linked to vegetation types across the Arctic. We have soil organic carbon map from Gustav Hegelius and others. We have global surface waters. This is from Landsat imagery, as well as watershed boundaries. So you can divide up your data according to watersheds. There's lake data sets, relatively coarse resolution over 10 hectares. And we will have this finer lake data set coming from Soraya and also from Ingmar. And rivers is another one. You might want to look at what early up in the river network or later, and also those lumps here from Ingmar's and projections as well, model projections of permafrost. That's another piece we can stick in there. And climate projections and glaciers and sea ice is another one if you want to look at coastal erosion. And I also want to mention there's the data set from Annette Barsch. She has mapped infrastructure across the Arctic, and that was published this summer in July, I think. So using Sentinel imagery, so we can have roads, and imagine putting her data set and combine it with Shandi's, and you can see right away where you have roads that are at high risk for issues with ice-rich permafrost thaw, for example. Or you can combine it with his maps of ice-rich degradation, and you have a road there. Then you might say this road will have complications if it doesn't have already. And here's a summary of different data sets we're envisioning including here. So if you have others you'd like to stick in there that you know of, please let me know. Shoot me an email, because each data set's become more and more valuable the more other types of data sets we have there that are relevant. And yeah, I think so. Two questions for you guys really is, what do you want? What kind of data, geospatial data, do you want to see added? And also, how do you want to interact with the data? So imagine you have this fluid Earth viewer with atmospheric data and anomalies of air temperature, for example, and it's in 15 kilometer resolution or coarser. How do you want to interact with it? How do you want to view the permafrost data on top of that? The ice-rich polygons, the lake change, or so on, and both from a pan-Arctic scale and zooming into a smaller scale. So I'm really curious to hear how you would like to work with the data. And I leave it at that. So here's the title of our project, and we have the webpage, and we have a Facebook. I have been a little bit poor keeping it active lately, and we have a Slack too, which we will wake up and use more now when we're at the stage of getting feedback from users of how to build the visualization tools. So I leave it at that and see if there's questions or suggestions. If you want to be part of the beta testing team, yeah, so thank you so much.
Thank you so much, Anna. That was fantastic. There's 30 plus participants on the line right now, including a handful from PGC. So we're going to open it up. If you raise your hand, or there's a question answer link on the bottom of the Zoom webinar. So if you press that and type in your question, Anna or I will read that off and do our best to answer, but we would love to have questions, and I'm sure Anna would love any feedback that you have.
Yes. Thank you.
I can ask one while we're waiting for hopefully some others to come in. So
Yeah.
you've been working with high resolution satellite data for a number of years now, correct?
Yeah. I personally, I haven't actually been myself. I should probably point that out.
Yeah.
So I work with people. So Shandi Vitarana, we collaborated for, we had an NSF project that's one more year on, where we started this mapping of polygons, and now Permafrost Discovery Gateway is a long one. So yeah, about three years that been in the works.
So this is a pretty wide-ranging question, but when you're dealing with such a large magnitude of data and products, what have you? I mean, it's amazing what you can do with this. What have you found to be some of the biggest challenges to overcome? Just thinking this big and dealing with data sources that are so large and vast.
Right. Yeah, I think to appreciate that there's so many aspects of making these big imagery products that you might, for example, Shandi, he rocks when it comes to deep learning and writing code for this optical imagery, but then his skills, you know, that's been teaming up with computer scientists and that knows how to write the code, present the code a little bit differently, and to combine it with existing tools in the high performance computing world to make it operational at the bigger scales. And I think it's both come at the same time also the importance of the pre-processing steps. And so one thing that Shandi found was the pen sharpening. That was really important, how that pre-processing was done, almost equally important as the training data set. So having the Polar Geospatial Center offering, you know, some of that support, that little bit different type of pen sharpening effect, and could make a big difference on the final results of the deep learning mapping. So one piece is I think really finding the people that are willing to listen and to learn, because you're coming from different discipline, remote sensing and computing science and computer science, and trying to figure out where are you and what can we do. It's a lot of talking, a lot of patience of trying to get the two languages to interact. And I'm really grateful for the team with NCSA and Kenton McHenry over there at University of Illinois, and they've been helping us taking that step into scale the code and make it faster, and also find the systems that have the GPUs and the resources to support that work. So I think once we've solved the ice-rich polygon part, then a lot of the same steps needs to be done to, for example, mapping the surface water using the optical imagery too. So it will be relatively easy to add on other types of scripts that are mapping slightly different things but using the same imagery. And I think another challenge that's out there is that I wish there was a better connectivity between data storage centers, the DACs, that it was more fluid of how the accessibility to the data. So wish it was more like a cloud platform,
yeah.
Really. So because we have so much data, there's so much we could do with it, and I think at the moment hindered a little bit by the accessibility of reaching in and doing stuff with that data. So that would require collaboration between many different agencies, and of course storing data at the cloud is very expensive too. So but on the other hand, you would, I think, enable much more science to be done if that was possible.
Okay. Thank you. So we do have a couple other questions that have come in. So I'll read these and then you can answer. We've got some folks from PGC on the line that can probably help as well. The first one is a question from one of the participants. How can I be part of the of this network as I'm working on the Himalayan cryosphere?
Oh, cool, cool. Yeah, no, I think go for it, because I'm hoping, my dream is that people will find this resource useful and a way to explore their own data and also other people's data and your own data combined with other people's data, so that this will become part of the Arctic Data Center long term. So instead of just putting data there and then like a library and forgetting about it, it becomes more as a learning platform where we can discover data and that it can expand to not just the Arctic, but also the Antarctic and other cold regions. And so at the beginning, I mean, if you have data in that part of the world, you would probably want to add geospatial layers that sort of, where you can combine your own data with, so it becomes even more valuable. So I think go for it. And if you have a proposal idea or such, you know, I'm sure Arctic Data Center and the NCSA would be interested in building up on this and expanding it too. So yeah, just because it says, I think don't limit yourself to, I was talking a lot about Arctic, but
Yep.
think bigger than that, I think so.
Great. The next one is from attendee. It just said, great talk, Anna. Does the Arctic Data Center have any opportunities for early career scientists? So this person just graduated with a master's. So they're wondering if there's any way for them to get involved and help developing these data sets.
Great. Yeah, maybe PGC folks have some ideas. I think from the Permafrost Discovery Gateway perspective, I think one way to be involved is to join our beta testing team. So, because we need to have a group of people that can test what we built before we make it public. And I think those people are really important too, because you can tell us, you know, this is how I want to interact with the data, because I might have my view, but you might have your view. So I think it's important to have that healthy number of people, different backgrounds, to provide feedback. So that would be a great way to yeah, become part and join us, and then you can go from there. And just shoot me an email or Jonathan or write something in the chat, and then I make sure to put you on our group.
Any other questions from participants, or any folks from PGC have things to either add to our talk or questions, follow-on questions? Okay, here's one that just came in.
Mm-hmm.
Are there plans to include other DEMs? So again, that's digital elevation models, such as IFSAR.
Oh yeah, yeah. Good point. Thank you. I'm going to write that down right away. I like that. Yes. And another product that will be included too. So Liljedahl will give a presentation here at the seminar a couple of weeks from now, and I'm working with her on her product Arctic mass wasting, and where she do DM differencing. So that will be another product to be included in here as well.
So Anna, I assume you're quite familiar with that, but just for the benefit of others that are on the talk, if they're not familiar with what IFSAR is,
right,
could you just briefly describe what it is and how you anticipate it potentially could be used in this?
Yeah, here, I mean, IFSAR, we got the DM, and so I think any kind of product that's derived from the IFSAR, and even if you have code that is working on IFSAR for smaller scaling, you're interested in applying it to Pan-Arctic, that let us know. We don't have someone on the team right now, like Shandi or Ingmar are not working with IFSAR. So if you see there's an opportunity there where a code is ready to roll for a larger region, let us know, connect with us, and we can explore and see if we can help you apply to the Pan-Arctic domain. So yeah, I think it's not just Landsat and Sentinel and worldview imagery that we can do cool stuff with. So this is one.
So this is a follow-on question is from somebody who had asked earlier, but this may be more direct for a follow-on for you, Anna, but I think it's probably beneficial for others to hear. Just said I'd be happy to join the testing team. This person has a doctorate in geoinformatics and uses a lot of satellite data. And is just curious if they should email you directly about their interest to join the team.
Yes, please do. Shoot me. It's right here. Yeah, Anna Liljedahl at woodwellclimate.org. Yeah, please do. That sounds great. With that background too. Thank you. And we will have something coming up here relatively shortly to get the group together and get some feedback, because association people at Arctic Data Center and Fluid Earth, you were there. knocking on the door to want to know exactly what we want to see.
Why don't we just wait really briefly and we'll see if there's, I'm really pleased to see some questions coming in. If there's, we'll just wait for maybe another half a minute or so and see if we have any other questions.
It looked like you had Fairbanks on the minute that you showed, Jonathan, in your slide. It looked like it was Fairbanks in the background of the DM. I think I recognize some pictures.
So Kathleen had put the slides together, so I just got them this morning. So
pretty sure it was
honestly I didn't look as closely at the background as I should have, but I imagine that's probably what it was.
Yeah, it's all that. Yeah, I'm in Homer, by the way. I'm working out of Homer, Alaska. So.
Okay. It looks like we probably answered all the questions that people have now. If I'll do a little wrap up here, but if there are questions that come in the meantime, I'll be more than happy to answer them, or Anna the same. Anna, could you give the screen? I should be able to do this here. Can you pass the screen back to me?
Yep.
All right, are you able to see my, that's not the one that I wanted. Are you able to see my screen right now?
Not yet.
Okay, let me try again.
No, they're happening.
Okay.
Yep.
Okay. So, yeah, without any other questions coming in, Anna, I want to very sincerely thank you for your time. You've, as we mentioned up front, you've been a longtime friend of the PGC. We really appreciate your role as serving on our Science Operations Committee, which is our steering committee. You and others have provided extremely valuable input there. We're really thrilled when we see what users such as yourself are able to do with this vast collection of data. And the Permafrost Discovery Gateway is a really strong shining example of what can be done when bright minds with diverse backgrounds come together just to see what's possible with diverse data sets. So we're really excited to see what you've been able to do so far, and even more so to see what's coming in the future with this. So thank you very much for your contributions over the years and for your presentation today. Again, this is a great chance to showcase what a lot of the users are doing. Mark Salvatore gave a great talk a few weeks back. I have this slide up. These talks will be available on our website afterwards, so we're recording these. So again, if for those that were able to see it today, it can touch back later, and also it'll provide an opportunity to more widely broadcast it to others. So the other ones that are coming up, I don't know if Kathleen has a date set yet, but Andrew Fleming, who's at the British Antarctic Survey, planning on giving a talk in early September. He served on the Science Operations Committee as well in the past, and has been a great user. So looking forward to his talk. Liljedahl from Ohio State University is giving a talk on September 23rd. and then Dr. Ellen Enderlin on September 30th. So for those that are on the talk today, we'd love to have you join any and all of the upcoming talks. And again, a huge thank you to Anna for your great talk today and for joining in. So thank you all so much for joining. Hope you have a great rest of the day. And we're proud to be putting on this series. So thank you, Anna.
Thank you so much, Jonathan. Have a great one.
All right. Take care. Thanks, everyone.